Hello dear students, as you all know that in our previous videos we have completed the first two exercise of unit 5, that is arithmetic progression. So in this video we will discuss about the exercise 5.3 and the formulas used in it. So first of all, let us go for the formulas. In this exercise we have to read about how to find the sum of n terms of an AP. That is, if we are given an AP, then how we can find the sum of n terms of the AP, like how to find the sum of first 3 terms of AP, first 4 terms of AP, first 5 terms of AP, or up to the last term of the AP. So the formula used for this is Sn. Sn, which denotes the sum of n terms, is equal to n upon 2 2a plus n minus 1 into d, where a, as we know, is the first term, d is the common difference, n is the number of terms. So this is the formula that we have to use in our this exercise to find the sum up to the n terms. If we expand this formula, if we write this 2a as a plus a, then we get a plus n minus 1 into d. As we all know that a plus n minus 1 into d is used for denoting the nth term, that is an. Then this formula takes the form Sn is equal to n upon 2 a plus an, where an is the nth term of AP, and in some cases we also denotes an as L, where L is equal to an, where we are given the last term of AP. So this is formula number A, formula number B, and formula number C, which we have to use in this exercise to find out the sum of n terms. Firstly, we have to again memorize these formulas. Sn is equal to n by 2 2a plus n minus 1 into d, then Sn is equal to n by 2 a plus an, then Sn is equal to n by 2 a plus l. Now let's move further. If we have moved towards in this exercise, then we have to also read about a formula where we have to find the nth term by the sum of the given terms, and we have to use the formula that an is equal to Sn minus Sn minus 1. Let's discuss how this formula is formed. Suppose we are given an AP like this. Here we have taken an AP as 2, 5, 8, 11, 14, so on. So here S1, that is sum of first term is 2. S2, that is sum of first two terms, 5 plus 2, 7. S3, first three terms, 8 plus 5, 13 plus 2, 15. S4, 26, that is sum of first 4 terms. S5 is 40, which is the sum of first 5 terms of this AP, and so on. So if we subtract S1 from S2 minus S1, it gives 7 minus 2 S5, and 5, if we go on AP, 5 is our second term. Again, if we subtract S2 from S3, that is S3 minus S2, we get 15 minus 7, which is 8, which is the third term of AP. In the same way, S4 minus S3 gives us 26 minus 15, which is equal to 11, which is the fourth term of AP. So from here we recognized, we appeared on the formula, we reach on a formula which gives us an as Sn minus Sn minus 1. That is, every term of AP is equal to the sum up to that term minus sum up to the preceding term of that AP. So these are the formulas Sn, Sn, Sn and An, which we have to use in this exercise. So now, after having these formulas, let's move further. Now, first of all, let's go for the proof of this formula, where we have to prove that sum of n terms of AP is n by 2 2a plus n minus 1 into d. Let's study about that formula. Let us consider an AP with the first term a and the common difference d. If the first term is a and common difference is d, then AP would be a plus d, a plus 2d, a plus n minus 1, a plus n minus 2 into d, a plus n minus 1 into d. Here I have taken the first three terms of the AP and the last two terms. As you know that last term of the AP is an, which we know a plus n minus 1 into d. If we want to find the term preceding the last term, then we have to subtract minus 1 from the n, and n here is n minus 1. If we subtract minus 1 from n minus 1, we get a plus n minus 2 into d. So this is our AP. So a plus d, a plus 2d, so on to a plus n minus 2 into d, a plus n minus 1 into d. So if we add this, we get sum as Sn, a plus d plus so on, plus a plus n minus 2 into d plus a plus n minus 1 into d. As you know, we are not going to take every term of the AP, so we have taken the first two terms and then we go for so on, which includes every term up to the last two terms. In the reverse order, as you know that 1 plus 2 plus 3 is equal to 6. In reverse order, if we take the sum 3 plus 2 plus 1, it also remains 6. So we have in reverse order the sum also remains Sn, and we have reversed the terms of the AP, that is a plus n minus 1 into d, a plus n minus 2 into d, plus so on to plus a plus d plus a. This is equation first, equation second. So now we have to add equation first and second. While adding first and second, this is our first equation, Sn is equal to a plus d plus so on to plus a plus n minus 2 into d. This is our second equation, a plus n minus 1 into d, a plus n minus 2 into d plus so on to plus a plus d plus a. While adding, Sn plus Sn gives 2Sn, and while adding equation first and second, we have to add the corresponding term. First term plus first term, a plus n minus 1 into d. In the same way, second term plus second term, a plus d, here is the second term, plus a plus n into d and d, 2 into d, 2d, plus so on. Then the second last term from the first equation is a plus n minus 1, a plus n minus 2 into d, which we get as a plus n into d and d minus 2 into d minus 2d, plus second last term from the last equation, second equation is a plus d, plus last term from the first equation is a plus nd minus d, and here is this a. So while adding, what we get, Sn plus Sn gives 2Sn, which we have taken here, a plus a, 2a, and minus 1 into d. Again a plus a, 2a, plus d minus 2d gives us d plus nd, plus so on. Again a plus a, we get 2a and d, and minus 2d plus d gives minus d. In the same way, here we also come with 2a plus nd minus d. So this is the first term, 2a plus n minus 1 into d. From these two terms, we can take d as a common factor. We left with 2a plus n minus 1 into d. In the same way, from the second last term, we can take d as the common factor. From this, we can take d as a common factor. We left with 2a plus n minus 1 into d. And in the same way, in the last term, we have 2a plus n minus 1 into d. So if we observe here, if we look here, we get 2a plus n minus 1 into d, 2a plus n minus 1 into d, plus so on to plus 2a plus n minus 1 into d, plus 2a plus n minus 1 into d. Here we are adding 2a plus n minus 1 into d n times. And if you know addition as the repeated multiplication, we know that the number of times we add a number, it becomes the multiple of that number. For example, if we add 1 3 times, it becomes 3, which is 3 into 1. In the same way, we have added 2a plus n minus 1 into d n times, so it becomes a multiple of n, that is n into 2a plus n minus 1 into d. And 2 is transposed to the, if we transpose 2 to the RHS, it becomes Sn is equal to n upon 2, 2a plus n minus 1 into d, which is the required formula which we need to derive, where we have to prove that Sn is equal to n by 2, 2a plus n minus 1 into d. So here is the formula that we need to derive. This is how to derive the sum of n terms, how to prove the sum of n terms as n upon 2, 2a plus n minus 1 into d. So next, now after that derivation of this formula, now let's move towards the exercise 5.3. So in exercise 5.3, question number 1, we have to find the sum of the following APs. Question number 1, we are given some APs whose sum we have to find. So I have taken part number 2 for you here. Rest of the parts you have to do by yourself. So in the second part, the AP we are given is minus 37, minus 33, minus 29, so on. And we have to find the sum up to 12 terms. So AP is minus 37, minus 33, minus 29, so on. So first term here is A minus 37, D A2 minus A1, that is minus 33 minus 37 minus plus, so common difference we find out as 4. Number of terms to which we have to find the sum is 12, that is n is 12. So we have the formula Sn is equal to n by 2 to A plus n minus 1 into D. So if we use these terms A and D here and n here as 12, 12 by 2 into minus 37 plus 12 minus 1 into 4, after solving these simplifications, we get S12 as minus 180. So sum of first 12 terms of this AP is minus 180. So then after moving towards question number 2, from question number 1 moving towards question number 2, we have to find the sums given below. Dear students, please keep it in mind, we have to find the sums. In question number 2, we have not mentioned about any type of AP in question number 2. So if we are just given a series of number, so firstly we have to prove that it is a AP. It is an AP, only then we have to apply the formulas of AP. So here the given series is minus 5 plus minus 8 plus minus 11 plus so on to minus 230. Here first term is minus 5, second term is minus 8, third term is minus 11 and the last term is minus 230. So to prove it as an AP, what we have to do is that we have to find the successive differences like A2 minus A1, A3 minus A2 and so on. If we go on finding the sums, we get the differences, if we go on finding the differences, we get the differences as A3 minus A2 is equal to minus 11 minus minus 8, which gives minus 3. In the same way, A2 minus A1 gives minus 8 minus minus 5, which is minus 3. So and so on. Since A2 minus A1 is equal to A3 minus A2 is equal to and so on, it means the differences are same. So given numbers are in AP, because we know that AP is a series of number in which the difference between the two consecutive terms is always same. So given numbers are in AP, and this AP, in this AP, the first term is minus 5, difference is minus 3. So let the given AP has n terms. If the given AP has n terms, then last term an is minus 230 we are given. So a plus n minus 1 into d, using the formula a plus n minus 1 into d is equal to minus 230, we get minus 5 plus n minus 1 into minus 3 is minus 230. So here from here we get, if we transpose minus 5 to the RHS, it becomes minus 230 plus 5. So n minus 1 is minus 230 plus 5 gives minus 225 upon minus 3. So n minus 1 is equal to 75, n is equal to 76. So Sn is equal to n by 2 a plus n, using the formula, because we can use the formula Sn is equal to n by 2 a plus an, where the last term of the AP is given. So since here we are given the last term as minus 230, so we can use the formula Sn is equal to n by 2 a plus an. So after using the formula, we get sum as minus 8930. So these are in this video we have discussed about the derivation of the sum of n terms and the formulas used in this exercise and the first two questions. In the next videos we will discuss about the rest of the questions of this exercise. Thank you very much.